Hey everyone, my name's Alex. I'll be your TA for Engineering 107 for the fall 2020 semester. In this series of videos, we'll be going through all of the CAD information that you need to know to pass this course. In this video specifically, we're just going to be going over some of the dead basics on how CAD works. So let's just get right into it. All right, hey everyone. In this video, we will be going over an introduction to CAD. This will just be a short presentation on all of the CAD basics you need to know going forward. So again, my name is Alex. I am the CAD TA for all sections of Engineering 107. So no matter who your professor is, I am your CAD TA. This is now my 6th semester being TA for Engineering 107, so I've done this for quite a while. I strictly focus on CAD and 3D printing. So I do not do any grading. So if you have questions on like assignment grades or test grades or anything of that nature, I'm not the person for that. Ask your professor. While I'm not supposed to necessarily help you with anything else related to the class other than CAD, I can help you with that, so feel free to ask me questions, but just know that's not my area necessarily. I'm focused almost completely on CAD. If you ever need to contact me, my email is right there. I'm very quick to respond to emails most of the time, so feel free to shoot me an email if you ever have any questions. So let's just jump right into it. So what is CAD? From previous semesters, it's typically about 50% of students have some experience with CAD, and the other 50% have never heard the term before. So I'm going to go forward with the assumption that you have no experience with CAD at all. So what is CAD? CAD stands for Computer Aided Design Program. These are virtual programs that run inside a computer that allow you to simulate real world things in a virtual environment. So the CAD programs we use are specifically mechanical design programs, but there's also electrical design programs, there's environmental design programs, there's aerodynamic design programs. There's a whole world of CAD programs out there. And it's great to be able to build something virtually because it saves you a lot of time, a lot of effort, and it doesn't cost you anything. CAD programs are something you will use for the rest of your life, no matter what engineering field you go into. Even if you go into a STEM field in general, you will be using some form of CAD program. So it's absolutely essential that you start learning it now if you haven't started learning already. More specifically, you will need to understand CAD fundamentals in order to pass this course. If you choose to ignore CAD and you do not end up grasping some of these fundamental concepts, you will not pass Intro to Engineering, and that's always embarrassing. So, make sure you pay attention. It's pretty simple. There's not much to it, and it's really fun once you get good at it. So, for the students who have used CAD before, you know that there's a lot of CAD programs out there. Many of you probably have used Inventor or Fusion 360 or SolidWorks before. We specifically use a program called Onshape, which is new to us this semester. Typically, we used Fusion 360 and Inventor in the past, but this semester we're using Onshape because it's very collaborative. It runs completely through a browser. It does not require an install, so any student can run it. You can even run it on something like an iPhone. It's very, very easy to use, but it's also very powerful in the functionality that it provides. So in order to set up an Onshape account, it's pretty basic. I'll actually be just demonstrating this at the beginning of the next video, but I just want to go over quickly here. Basically, all you're going to do is make sure, first of all, your browser's up to date. You can't be using some old ancient browser. And then just go to onshape.com and begin your account registration. Once you actually create an account, make sure you sign up for the Autodesk, sorry, not Autodesk, Onshape education plan, and use your Mason Live information and email, or just your GMU email, because this will enable you to get the upgraded education account rather than just the normal free account. And by getting the education account, you just get more features, which could be helpful if you want to actually explore this CAD program further. Once you get to it, it's going to ask you for a lot of information. I'll show you all of this in the next video. So getting started, just looking at some very basic features of how CAD programs work, specifically Onshape. There's some important terms to know. First of all, a part. When I say a part, I'm talking about one solid object. You might think of it like, I don't know, what's a good example? Like this hand sanitizer bottle. This is one physical piece. It is other if you take off the lid, it is one solid universal part. There's no subcomponents to it. When I say an assembly, I'm talking about something that is multiple parts put together. So for example, a Rubik's Cube. A Rubik's Cube is a bunch of these little small parts all fit together. And you could take it apart, if I can actually do that here. So like I have an individual part, but all of these parts work together to make an assembly. So it's very important you understand the difference when I say a part versus an assembly. In Onshape, we make all of our parts in a part studio. And then once we have a bunch of parts, we do something called mate. We mate all the parts together in order to make an assembly. And I'll be demonstrating all this in future videos. So Onshape workflow is fairly straightforward. If any of you have used Autodesk Inventor before, Onshape workflow is identical. Basically, you'll have one area where you make parts, and you'll have another area where you combine those parts together to make assemblies. So you go into your part studio, you make a bunch of parts, you go into your assembly, you assemble those parts together. You place them out, you mate them, and you get your assembly. So just some very simple CAD basics. There's a few things that you have to understand about CAD programs, but they all revolve around a few key features. And we'll be going over some of them here. One of the most important features of any CAD program is understanding how to use Sketch. If you think about it, in a CAD program, you're trying to make a 3D object, but your computer screen is a two-dimensional surface. So how do you make a three-dimensional object on a two-dimensional surface? And we do that in a two-step process that always starts with a sketch. So whenever you sit down on your CAD program at your computer and you want to make something, you always start with a sketch. Sketches are just two-dimensional drawings of what you want your final piece to look like. That is always the first step. So if you don't know what you're doing, think, do I have to start with a sketch? Once you have these two-dimensional sketches finished, you can do something what we call an extrude, which then pulls that two-dimensional object out into the third dimension. And so it's through that two-step process of sketching then extruding that you can actually make your three-dimensional objects. So every single part in any CAD program is made through this two-step process of making a sketch, then making extrusion. That is fundamentally all you will be doing this semester in CAD, is sketching, then extruding. And we throw in some twists and some flavoring along the way that we'll show you. One important step, as any engineer knows, is making sure your dimensions are correct. So making sure you're using the right units, making sure that things are properly proportioned. It's very important to know whether your part is an inch long or a mile long. So that's where we use something called the dimension tool to make sure that you have the proper size constraints put on your sketch or your part. So that will be very important to go forward on. And finally, I'll show you guys how to make drawings. Drawings are very simple ways of showing your three-dimensional part to a grader or to your professor or to someone else. Without having to pull up a CAD software and view your object in 3 dimensions. So I'll show you how to do drawings later. And then finally, we have 3D printing. In previous semesters, we have allowed 3D printing as an optional part of the course, or as a required part of the course. This semester is a little bit different, obviously. If you want to 3D print, you can send your file to the Mix at Innovation, and they have appointments to allow people to come in and either use their 3D printers, or you could just send them the file and they'll 3D print the part for you. If this is something that you're interested in, or is something for like maybe extra credit for a class, you have to contact the Mix at Innovation directly, or reach out to me and I can help you. Just make sure you have your file as a .stl, and I'll show you all how to do that later. So, some resources to learn Onshape. First of all, my office hours. Currently, my office hours are by appointment only. I will hopefully have them up and running in, very soon, hopefully by mid-September. I will have regular weekly office hours, and they'll be posted on your Blackboard. So you could just join in when I have those office hours. But if you need my help anytime soon, just shoot me an email and I could get on a Zoom call within about 24 hours after you send me that email. And then once I do have regularly scheduled office hours, if those times don't work for you, you can always just shoot me an email and I'll find a separate time to work for you. There's a lot of great built-in tutorials on Onshape. If you go to learn.onshape.com, there's a lot of walkthroughs, very specific videos that you can watch about very specific topics. These go into a lot more depth and have a lot more focus than the videos that I'm producing here. So if you want to learn more about something or you're just quite not understanding a specific topic, feel free to go through these tutorials. They're great. Additionally, there's a lot of other tutorials. My tutorials are only one of thousands of CAD tutorials on YouTube. Any one of these YouTube tutorials that's up to 30 minutes long will cover everything we will be doing this semester in terms of CAD. So go through one or two of these other tutorials, and I'm certain that will cover 90% of what we're going through in this course. Just to wrap up this presentation, I want to talk about some opportunities on campus. If any of you are interested, I know a lot of you are freshmen coming onto campus for the first time, and you might be interested in getting involved in some organizations. One of the organizations I run is the Hypernova Solar Car team. What we do is we build full-scale road legal solar-powered vehicles, and we try and race them in international competitions against teams from all around the globe. We're one of very few engineering organizations that are active this fall. So if you're looking for something to do, I know a lot of clubs are shut down, but we are well on our way to continuing building our first car. So if you're looking for something to do this fall, this is absolutely an opportunity. Our members do a lot of cool things. Our mechanical members learn how to weld and learn how to use CAD programs to simulate our car's environment. Our electrical and software members learn how to build full-scale CAN buses and run battery management systems and control motors and awesome stuff like that. We also have a lot of awesome side projects. One of our side projects was building what we believe to be the largest 3D printer in Northern Virginia. It's a 216 cubic foot hanging printer that we're using to actually 3D print the majority of our car's aeroshell. So like the bumpers, the hood, the doors, those are all 3D printed. And we built this printer from the ground up, so it's really cool. So if you're interested in that, shoot me an email or go to our website and fill out one of our application forms. Our meetings are every Friday at 3 p.m. hosted via Zoom. And sorry. You can find out more information on our website or just shoot me an email. So that wraps it up for this presentation. I'll see you all in the next video where we'll actually get started using Onshape together.